Hey, welcome. Today we're going to be talking about how a phone camera can display and take pictures. Specifically, we're talking about pixels, photosensors, RGB displays, which is red, green, blue displays, how they all work, at least the basics of them. And our end goal is for this unit to be able to understand how someone could take a picture and send that to a buddy. So I do want to start off with something that's a little bit different because I do want you to think differently about how we can visualize things. My question is, which letter is darker, A or B? Take a look up here. And the answer is neither. It's an optical illusion. I want you to think about how we see color and start to upend some of those ideas if at all possible. It's a little easier to see if I show you this picture over here. It just turns out that A is on a darker background and B is on a lighter background, at least over here and over here. And so it's hard to tell based on the background. Our eye interprets things in different ways. So let's think about these concepts about how our eyes interpret light and the different colors of light. And so let's continue and think about pixels. So a pixel is just a smallest single component of a digital image. So it's a small square typically, but it can take other shapes as well, like dots or lines or something called smooth filtering. So what we can do is think about, all right, at a certain location on the computer screen, you could think about like an X and Y axis. At that time, there is a color that's projected on the screen, and the combinations of those pixels that forms an image that our brain interprets. Our brain is actually very good at putting together a meaning based on images. What I want to do next is take you to a site called Physics. Physics is fantastic. I will put a link to this physics simulation site when I get a chance down below in the comments section. And here it is. Physics has lots of different simulations, but the one we're going to take a look at today is this one over here. This one we can mix lights. The reason why red, green, and blue are so important for our vision is because those are the colors that we can absorb in the back of our eyes. Red light, green light, blue light, because we have typically red, green, and blue photoreceptors in the back of our eyes. If someone is colorblind, they're missing one or more of those receptors, and so their version of color is different from other folks' version of color. But in any case, with this really amazing site, what you can do is drag these lights around, and you can get a feel for how light in terms of color is created in an additive sense. If we include red light, blue light, and green light together, we get white. You can also change the intensity and see what happens to the colors in terms of where they overlap and get an idea. With this, we can create all of the colors of the rainbow just by changing the intensity of these different colors. And so we use this to produce images. Whenever we use displays, we use these three colors, red, green, and blue, typically, RGB monitors, and use different intensities, and based on that, our brain interprets these things as different colors of light. Alright, so here is another way of looking at an RGB screen close-up. You can see the pixels, and the pixels right next to each other are RGB, red, green, and blue. And if they are all lit up with the same intensity, you're going to get a white color if you're able to be back from the screen a bit from this image. This image is a close-up image of what's going on with pixels, but the same principle applies. How can we see a picture that a buddy of ours has sent to us? Well, through this additive mixing of pixels. Our brain interprets these as different colors, and since they're at different locations, that is put together by our brain as an image. Let's take a look at another way of thinking about this. I talked about how the different colors and combinations of colors are going to be represented here. You can get green, for instance, if you tone out completely the red and the blue. Notice we just have green over here. How about something in between? How about cyan, which would be completely blue and green? That would be a combination of both blue and green. So all of the colors of the spectrum you can get by doing this, by combining different types of colors with different intensities, similar to what I just showed you on Physics, but this is just another way to visualize what's going on. Alright, so that's how displays work in terms of different colors, and pixels can combine into different colors. How can an image be taken though? So how do we get information into a camera, a digital camera? So let's think about how this works. First, we need to talk about what color filters are. So if we have white light coming in and a yellow filter, remember we said yellow light is going to be with an absence of blue. It's going to be a combination of green and red. So if we have a yellow filter, that only allows green and red light and combinations thereof to pass through. The blue is stopped by the yellow filter. And after that, if we have a red filter that only allows red light to pass through, these are examples of filters down below. So filters can subtract light colors or light frequencies out of the light that we're dealing with. And that's important to know for what I'm about to explain. So we use this property when we design image sensors for cameras. So we have filters. If this is a side view of light that comes into the camera, if you have a filter in the camera like this, and then the top-down view, we will have, like, say, red receptors on metal down here, kind of represented by this over here, at only specific locations. And then in other locations in this pattern, we're only allowing green light to pass through, and then in other locations, we're only allowing blue light to pass through. So if this grid has a little part that gets stimulated by light, we know that, for instance, blue light can only be appearing here. So if this part starts kicking off electrons, then we know that blue light has hit this surface of metal right here. And how does that work? How do electrons get kicked off of a surface of metal? Well, that's based on something called the photoelectric effect. I've done a whole screencast on that. I will put a link to that screencast up in the upper right, but just know that if you have an energetic wave, an electromagnetic wave that's energetic enough, it can knock electrons off of the surface of metals. And what that does is it sets up an electric current in a circuit. So you can actually understand now how light can get in only to a certain location, like with the blue filter. We know, therefore, that there is blue light hitting this surface right here, and the amount of current is related to the intensity of the light, how great the amplitude is. So if it's very great in the blue spectrum, then what that means is you're going to get a large current right here. The camera can read this and put all of this information together, and it can actually assemble this into a picture, digitally speaking. It's pretty amazing how this all works, and I think at this point, if you've been listening along, you may be able to understand how a camera is able to take photos, which is the purpose of this screencast. So hopefully that makes sense. If you have any comments down below, please let me know. I've gone through just about the entire year of major physics concepts, and this is a related concept in kind of a side unit, and the purpose of this unit is to figure out how you can take a picture and send a picture to a buddy. So if you're interested in more physics concepts, subscribe, like the video, or take a look at the playlist in the description below. Take care, have a great day.